primary mission of the field artillery is support of the infantry and armor. Its weapons must sustain the fast-moving capabilities and wide dispersion of these ground-gaining arms in the strategic and tactical complexities of modern warfare. The requirements of this mission, therefore, range from close support to long-range nuclear fire support of the field army. To meet these requirements, the field artillery maintains high explosive and nuclear capabilities in cannon, free rocket, and guided missile systems. This full range of capabilities sustains the field artillery's established reputation as one of the greatest casualty-producing agencies employed on the field of battle. Whatever its assignment and mission, each field artillery weapon must be in position and ready to fire at the appointed time. To accomplish this, three basic characteristics are essential in its design. Mobility. Artillery must be at least as mobile as the ground-gaining arms it supports. It should be capable of cross-country operations and negotiating inland waterways. Whether its mission is to support an infantry unit or an entire field army, it must be able to move over terrain at relatively high speeds. Stability. In order to maintain the high accuracy provided by modern fire direction center techniques, the emplaced weapon must withstand the shock of firing and remain in place. Flexibility. The ability to deliver fire over a wide front and at high angle of elevation without time-consuming shifts is further essential to support widely dispersed units. The towed 105mm howitzer M101A1 is the light artillery weapon of the infantry division. Capable of close and continuous fire, it normally functions in a direct support role. Stability is provided by the split trails which are spread to emplace it in the firing position. This 2½ ton weapon can be manhandled by its 8-man crew and emplaced in about 3 minutes. On-carriage fire control instruments include the range quadrant, used in laying for elevation, and the panoramic telescope, for laying for direction. Minimum elevation is minus 89 mils. Maximum elevation is 1,156 mils. A pintle-type mechanism allows 809 mils of traverse. This weapon fires semi-fixed conventional ammunition, hurling its 33-pound projectile to a maximum range of 11,000 meters. Like other field artillery howitzers, it also has direct fire and high-angle capabilities. Maximum rate of fire is 10 rounds per minute for 3 minutes, and the sustained rate of fire is 3 rounds per minute. There are 3 batteries of 6 towed 105mm howitzers in each battalion, and 3 battalions in the Infantry Division Artillery. The towed 105mm howitzer M102 is almost 1 ton lighter than the M101A1 and is a weapon of greatly increased flexibility. A ball and socket type traverse provides a full 6,400 mil traverse capability. It can be moved not only by jeep or helicopter, but parachuted into areas otherwise inaccessible as artillery positions. Its longer tube is designed to fire either standard or extended range ammunition. An extended range capability allows engagement of targets at up to 14,800 meters, a 3,300 advantage over standard range ammunition. An increased maximum elevation to 1,333 mils permits attack of extremely close targets with high-angle fire. The same tube as on the M102 is employed on the self-propelled 105mm howitzer M108. On this weapon, the tube is fitted with a chamber evacuator to pull gases out through the muzzle, providing crew comfort and safety. The full 6,400 mil turret traverse of the M108 gives it the flexibility required in modern self-propelled cannon artillery. Traversing is accomplished manually. Elevation is also manual, from a minimum of minus 106 mils to maximum of 1,333 mils. It fires both standard and extended range ammunition. Loading is accomplished manually. The rates of fire are the same as the towed versions. Recoil is held to only about 12 inches by a concentric hydrospring mechanism. With its small crew of 7, the self-propelled 105mm howitzer has space in the crew compartment to carry an ammunition load of 87 complete rounds. Through the use of aluminum armor plate, the M108's 24-ton combat weight is 4 tons less than that of the earlier self-propelled 105mm howitzer. Its 450 horsepower diesel engine sustains a cruising speed of 35 miles per hour and a range of 220 miles. The towed 155mm howitzer proved its combat effectiveness beyond doubt in the global theaters of operations during World War II and in Korea. The M114A1 model, which also has a nuclear capability, weighs 6 tons. It is normally towed by a 5-ton truck which carries its crew and ammunition. Emplacement of the towed 155mm howitzer takes about 5 minutes. Stability is provided by 3-point suspension, 2 of which are the welded steel trails spread at wide angles from the carriage. The 3rd point is provided by the firing jack on the bottom carriage, which supports the weight of the front part of the weapon when the wheels are raised from the ground. The gunner lays for both deflection and elevation. Its maximum traverse is 448 mils to the right, 418 mils to the left of center. The projectile is inserted and manually rammed. Maximum range for the 95-pound high explosive projectile is 14,600 meters. Like traversing, elevation is manual, from a 0 minimum to a maximum of 1,156 mils. A variable recoil mechanism makes high-angle fire possible without digging a recoil pit. Sustained rate of fire is 1 round per minute. Maximum rate of fire is 4 rounds per minute for 3 minutes. 3 batteries of 6 weapons each are assigned to Infantry Division artillery. Like other howitzers, this weapon can also handle direct fire missions effectively. The self-propelled 155mm howitzer M109 employs the same diesel engine, chassis, and transmission as the M108. The weapon is serviced by a crew of 10 and carries 28 complete rounds of ammunition. The increased shock of firing extended range ammunition requires use of spades to maintain weapon stability. The separate loading ammunition is standard or extended range, conventional or nuclear. Loading is accomplished by aligning the tube with the power rammer. The projectile is rammed by a hydraulically powered system. The weapon's sustained rate of fire is 1 round per minute. Its maximum rate of fire is 4 rounds per minute for 3 minutes. Hydraulically powered traverse and elevation mechanisms can be operated from the gunner's position. The turret traverses rapidly through a full 6,400 mils, and power elevation raises or lowers the tube between minus 53 mils to maximum elevation of 1,333 mils. It fires standard ammunition to a maximum range of 14,600 meters. And extended range ammunition up to 18,100 meters. Recoil is variable, and its force is checked by a hydropneumatic recoil mechanism. The muzzle brake also helps to reduce recoil. Toxic gases are kept from passing back into the cab by the chamber evacuator. This full-tracked, armored, highly mobile support weapon is found in units of the Armored and Mechanized Infantry Divisions. The 8-inch howitzer M115 towed adds a devastating extra punch to division artillery. The combat-proven 8-inch howitzer is one of artillery's most respected weapons. The M115 howitzer delivers its 200-pound projectile on targets at ranges up to 16,800 meters. And is considered to be one of the most accurate weapons in the cannon artillery of the United States Army. Because of its size and weight, this 15-ton weapon requires a longer emplacement time than smaller caliber towed weapons, about 20 minutes. The steel trails are lowered from the prime mover utilizing a chain hoist, spread, and securely emplaced with the rear spades. When the howitzer is lowered to the firing position, the front spades stabilize the bottom carriage as the firing base. Total traverse is 1,066 mils, 533 mils to right and left of center. Like elevation and loading, traverse is accomplished manually. The projectile and charge are inserted at the loading elevation prior to laying for quadrant elevation. The maximum rate of fire is 3 rounds per 2 minutes, and the sustained rate of fire is 1 round per 2 minutes. Elevation limits are minus 36 mils to maximum of 1,156 mils. The manual effort of raising the tube is greatly reduced by the pneumatic lifter type equilibrators on each side of it. A braking system holds the heavy tube at any angle of elevation during firing. Variable recoil, which is shortest at high angle fire, is automatically adjusted as the tube is raised or depressed. It varies from 29 to 70 inches, as shown on the recoil indicator. One battery of towed 8-inch howitzers is included in the Infantry Division artillery. The self-propelled 8-inch howitzer M110 employs the same tube as the towed weapon. Range, rate of fire, traverse, and maximum elevation limits are the same as those of the towed 8-inch howitzer. However, traverse, elevation, and loading are accomplished on the self-propelled weapon with hydraulic power. The hydraulic power system greatly increases the speed with which the M110 can engage its targets in its usual general support role. Hydraulic operation of the recoil spade and suspension lockout system, which stabilizes the weapon for firing, reduces its emplacement time to 2 minutes, greatly enhancing its mobility from one firing position to another. It carries 5 members of the 13-man crew, the rest traveling in a personnel carrier. Designed specifically for artillery purposes, this rugged, efficient carriage is capable of high speeds on average roads, but can also handle rough terrain, snow, and mud. Its cruising range is 375 miles. Air transportable, the self-propelled 8-inch howitzer is a division, corps, or army support weapon. The self-propelled 175-millimeter gun, M107, is impressive proof of the essential versatility of the carriage, which mounts it interchangeably with the 8-inch howitzer. Emplacement time for this formidable long-range gun is only 3 minutes. The shock of its firing is effectively harnessed and transmitted directly to the ground by the suspension lockout system and recoil spade. Separate loading ammunition is handled by the hydraulically operated combination loader and rammer. In one operation, the projectile weighing 147 pounds is picked up and positioned, inserted into the breech, and automatically rammed. The right and left limits of the hydraulically operated traverse, 533 mils, are the same as those for the 8-inch howitzer. A maximum elevation of 1,156 mils. The variable recoil and rate of fire are the same as the 8-inch howitzer. The maximum range of this corps general support weapon is 32,800 meters. Concepts of modern warfare are projected upon a battlefield greatly expanded in depth, both in front and to the rear of the forward edge of the battle area. This approach is made possible and necessary by the development of rocket and missile artillery weapons. Mobility and flexibility, the basic characteristics of these weapons, are essential for furnishing the continuous fire support demanded by the greatly increased frontages and wide dispersion of units in modern battle. 115mm multiple rocket launcher M91 is designed to be transported by ground or air. 3 launchers are assigned to the Direct Support Artillery Battalion when authorized by the theater commander. The 45 rocket tube openings in the cluster, arranged in 5 tiers of 9 each, are stabilized by 2 jack groups and 2 trail assemblies, which are staked into the ground. The launcher is laid for both direction and elevation in the same manner as cannon artillery and fired electrically. The 318mm rocket MGR-3 Alpha, called Little John, is a simple, reliable, lightweight, general support, surface-to-surface, solid propellant rocket system. Little John carries a 260-pound warhead, either conventional or nuclear. The warhead is mated to the rocket motor section, and the complete round receives detailed inspection and electrical checkout in the assembly area. To maintain an even propellant temperature, an insulating blanket is installed on the Little John as soon as it is removed from its shipping container. Fully assembled, the round is 14½ feet long and about a foot in diameter. With handling bars, its 780-pound weight can be moved manually into place on its aluminum alloy launcher. The entire unit can now be towed with full ground mobility and even manhandled for short distances, airlifted in parachute and air assault operations, or transported by helicopter to the prepared firing position. And placement here, preparatory to the firing sequence, takes about 10 minutes. The Little John launcher is stabilized by 2 jack assemblies and a rear support, providing a level base for firing. The insulating blanket is removed from the rocket just prior to firing. The launcher beam, which supports the rocket for firing, is elevated manually. Maximum elevation for the Little John is 978 mils. With traverse limits of 267 mils right or left of center, the weapon is aimed similarly to cannon artillery. Low-level surface winds, which will affect it during its acceleration phase, require measurement for speed and direction by the wind measuring set. These indications are transmitted in electrical signals to the fire control station, converted into miles per hour, and then mils for launcher deflection and elevation correction. About 12 to 15 minutes are required to emplace and fire the Little John. Accuracy is obtained through a spinning action applied to the rocket before firing by a spring-driven motor at the rear of the launcher. When the rocket reaches a rotational velocity of 3 revolutions per second, an igniter sets off the propellant. The range of Little John is 20,000 meters. The 762mm Honest John rocket, MGR-1 Bravo, is an improved version of the first operational field artillery rocket system. In the assembly area, the rocket, with its propellant protected against temperature changes by electric heating blankets, is assembled utilizing a wrecker or the traversing beam of the M405 handling unit. As soon as the rocket motor is positioned on the handling unit, a specialist begins its inspection and checkout. The Honest John warhead, either conventional or nuclear, is assembled to the rocket motor with 4 mating bolts. Assembled, the complete round measures 25 feet in length. It weighs approximately 2½ tons and is transferred to the launching beam of the self-propelled launcher by either the wrecker or the M405 handling unit. It is secured by steel shoes, which will guide it up the rail-type beam when it is fired. For travel, the launching beam is folded back. With the assembled rocket in place, the 17-ton M386 launcher has the mobility of medium artillery. Both rocket and launcher can be transported in cargo aircraft. Emplacing the weapon at the firing position takes the 13-man crew about 15 minutes. The launcher is stabilized with 3 screw-type jacks and can be cross-leveled to compensate for cant. The beam assembly is extended for firing at the firing position, locked and the blankets removed. The rocket fins are attached. Sighting and laying procedures, including bore sighting and the use of gunner's quadrant and panoramic telescope, are like those used with cannon artillery. Direction and velocity of low-level winds used in deflection and elevation calculations are measured by the trailer-drawn wind measuring set, which is equipped with a hydraulically elevated 50-foot mast. The launcher's hydraulic elevation raises the launching beam to a maximum 1,244 mils. And its manually operated rack and pinion mechanism traverse allows 266 mils right and left of center. The Honest John firing sequence takes about 10 minutes. Final firing data are applied at X-2 minutes. To reduce the effects of thrust malalignment, the Honest John is equipped with 4 spin rockets that cause it to rotate after it leaves the launcher rail. It is fired electrically with thermal batteries or vehicular power source from a remote control firing panel. In less than 4 seconds, the propellant is burned, delivering 110,000 pounds of thrust to launch the Honest John to a target as far off as 38 kilometers. 1 Honest John battalion is assigned to each infantry, mechanized infantry, and armored division. The Sergeant Guided Missile System is an all-weather, all-terrain, nuclear-capable weapon with quick reaction time, rapid employment and displacement, rugged, reliable, simple in operation, and immune to known countermeasures. The backbone of the Sergeant Guided Missile System is the 8½ ton launching station, which carries all the equipment necessary to assemble, to program, to orient, erect, and to automatically fire the missile. 3 hydraulic jacks provide 3-point suspension for the launching station at the firing point, stabilizing the platform on which the missile is assembled and fired. When the launcher is leveled, the superstructure is raised hydraulically. Missile sections are brought to the launcher for assembly. Coordination of equipment and procedures enable the Sergeant Guided Missile System to occupy its position in about 8 minutes. The rocket motor and guidance section are hung and locked to the underside of the launcher boom. The guidance section is the essential difference between shorter-range free-flight rockets and the Sargent system. The Sargent guidance section is mated to the rocket motor by 4 bolts. The warhead section, containing the nuclear warhead and arming and firing circuits, requires no pre-firing checkout by the crew, since all checks are performed automatically by the firing set at the forward end of the launching station. The firing set enclosure houses all the electronic components necessary for the launching. The firing set computer, which programs the missile for launching, processes the firing and target data while the missile sections are being assembled. The Sargent missile assembly is complete when the warhead is bolted to the guidance section and the missile's control surfaces are locked into place. It is now ready for the automatic countdown. The guidance platform is aligned with the firing azimuth by the azimuth orientation system. And as the small Sargent crew clears the area, the automatic countdown is now at X-10 minutes. At X-3 minutes, the firing set operator leaves his enclosure to monitor the final moments of the automatic countdown from the remote firing position. During the final seconds, the missile is automatically elevated 5 degrees, slews to the firing azimuth, and rises to its firing elevation of 75 degrees. The range of the Sargent is from 25 to 75 nautical miles. With these outstanding capabilities, the Sargent guided missile system is normally assigned to the Field Army with a mission of general support to a corps. The Pershing guided missile system is the United States Army's longest-range field artillery weapon. Maximum tactical mobility is achieved by mounting the firing battery equipment on 4 vehicles. Lightweight, tracked or wheeled vehicles may be used. The Pershing system is air transportable and can be employed at environmental extremes of temperatures, in high winds, high humidity, low visibility, and darkness. The warhead vehicle carries the Pershing warhead section, the missile air fins, and other operational equipment to the firing position. The erector launcher supports the missile during transit, provides a platform for mating it to the warhead section, and for test, checkout, and azimuth laying operations. It erects the missile and provides a level, stable platform for its firing. A third vehicle carries the power station and the programmer test station, which determines the missile's flight worthiness, computes the firing data, and inserts the guidance presets, and energizes the missile for flight. The radio terminal set and placed away from the firing point is the core of the Pershing specially designed unique communication system, utilizing a tropospheric scatter radio highly immune to jamming and interception. Its long range and high reliability permits launching operations to take place up to 100 miles away from Pershing Battalion headquarters. The erector launcher is continually leveled and stabilized by automatically operated jacks. The warhead section is mated to the first and second stage rocket motors and the guidance and control section. The missile is designed to lift the warhead from the Earth's surface to a point in space and release it with sufficient velocity at the desired angle and direction to follow a true ballistic trajectory to the selected target. Before erection, the assembled missile is tested and checked out with equipment in the programmer test station. There, the guidance presets are worked out by the fire data computer. Before flight, the firing azimuth, velocity, and displacement are inserted into the missile's inertial guidance system. During the firing sequence, signals from the programmer test station control the functions of the erector launcher. When the missile is erect, the launcher rotates it to the firing azimuth. After a final monitoring phase, control of the missile for firing is transferred to the remote firing panel about 150 meters away. Following the initial thrust provided by ignition of the first stage rocket motor, the missile enters a coast period, preset into its guidance and control system, which varies with distance to the target. Following the coast period, the first stage is separated and the second stage ignited, accelerating the missile on its flight path. With termination of second stage thrust, the warhead is separated from the guidance and control section and spin stabilized to maintain its trajectory. Clean separation of the warhead is ensured by explosive rupture of the second stage motor. The warhead itself, specially coated against aerodynamic heating, re-enters the Earth's atmosphere. The Pershing's range is 400 miles, and it is normally employed in general support of a field army. Whether deployed for nuclear combat or close infantry support in the field, the ground-gaining forces can continue to rely on the techniques, the men, and the weapons of the field artillery.